Welcome back. Today's lesson is going to be on computer-aided drafting and design. Some places will just call it CAD with a single D. They'll refer to it as computer-aided drafting. They'll refer to it as computer-aided design. We like to think we do a little bit of everything here at Central Dauphin, so we just like to call it computer-aided drafting and design. So let's get started on today's lesson. Okay, so our essential question, what is CAD? You should have all had a little experience with this in middle school, so some of this should be review, but we'll go over it again here. Before CAD, before there was computer-aided drafting, it was table drawing. We did everything on the table. We drew them on paper that we could make things called blueprints off of. It was really the only way you could share drawings with each other was to make a copy of them. Editing was difficult. It was difficult to share them with people. CAD makes that a lot easier for us today in industry. All manufactured objects need accurate CAD drawings in order to be made. Accurate drawings are also needed to obtain a patent if you come up with a new idea that you'd like to patent for an invention. Everything needs it. You think of a number 2 pencil, just a regular old wooden number 2 pencil, there will be a packet of drawings on how to make that accurate. CAD makes drawings more accurate, easy to transmit to others, and can be taken directly to computer-controlled machines called CAM, computer-aided manufacturing. We have some computer-aided manufacturing machines over in the CAD lab that we use in our design and automation class, where we do some robotics. CAD can be more accurate. You're drawing most of the time usually to 1/1000th of 1 inch, which is like taking a hair and splitting it about 3 times. They can even be set to draw even more accurately than that. Easy to transmit. If you're working with somebody in the West Coast over in California, you need to share a drawing with them. Very easy to do. You can be working on the same drawing at the same time. Makes life a lot easier for industry. Makes production go a lot faster. Now, one of the type of drawings that we will be doing in here is called an orthographic projection drawing. It is a type of a multi-view drawing. You've probably used these terms in middle school. So what is a multi-view drawing? A multi-view drawing is where you're looking at an object one side at a time. You try to draw this thing like it is not in perspective, like it does not get smaller as it gets further away from you. The glass box principle is where the sides of an object projected onto a box. If you were to cut that box open and lay it flat, all of the views will align with each other, meaning that this side of the front view aligns with this side of the top view and this side of the bottom view. As we measure across, draw lines across, everything lines up. This little corner here lines up with this feature. It also lines up with this hidden line. When we look at it from a left side, we don't see it. It's hidden because it's behind this object here. Here's our sloped surface. Typically, we draw a multi-view drawing and we think about, gee, which views do we need? Every object has 6 orthographic views to it. The front, the back, the left, the right, the top, the bottom. This would be kind of an orthographic projection view of a car. So when we look at these, what are our standard views? We don't draw them all, we only draw those what we need to. The typical views that are usually drawn on an orthographic projection drawing will be the front view, the top view, and the right side view. These 3 views for most objects will give us all of the information needed to manufacture this part. And you can see how it represents on this, which is called an isometric projection drawing, which we will look at next. So you see how everything lines up with our views. Now, there are some different line types we should talk about. In the drafting industry, we have standards, meaning that somebody drawing something here in the United States is drawing to the same standards of somebody drawing in, say, Europe or China. We're using the same type of lines, so that way when we share our drawings, we all know what we're looking at. So lines are used to represent different features of a drawing. Part outlines, the actual physical lines of the object, are usually a dark, bold line. If you're looking for exact measurements, this would be 0.7 millimeters thick. Section lines and other features, these lines are still dark, but they're about half the thickness of this. If this is 0.7 millimeters wide, this would be 0.35 millimeters. Same for hidden lines. Hidden lines represent objects that we can't see. They're hidden behind something else. Center lines are used to represent symmetry in an object. Think about a butterfly. You would draw a center line straight down through the middle of the butterfly. Circular objects, we use center lines to represent centers of holes. And like I said, symmetrical objects. Dimension lines and extension lines, we have to put dimensions on an object so we know how big to make it. Those are also thin lines, about 0.35 millimeters thick, still dark. Cutting planes, break lines, we don't use them too often, especially in anything we're doing in here right now, but these are lines that you would discuss if you take more detailed technical drawing classes. There are also many dimensioning standards, and again, we all do this, so we all follow the same rules. A drawing needs to be dimensioned in a way that is understandable by anyone in the industry. Standards have also been developed on how we dimension out a drawing so that it looks professionally complete. Here are some of the dimensioning standards that you may actually see in a quiz, but don't worry, you won't have to memorize these. The PowerPoint will be available for you to look at. Some of these things that we look at for conventions. How high do we typically make text on a drawing? It's typically going to be 1/8 of an inch tall. That's actually a little smaller than you may be used to drawing by hand, but it's about the same height as 12-point text in a Word document. Some other things that are important to know. Notice that these extension lines, they extend out from the object. They don't really touch the object. There's a little break in here of about 1/16 of an inch. This thing called a dimension line, the line with the actual arrowheads on it. Again, they're also a thin line. We break them in the middle typically, put the dimension in it. Arrowheads are typically 1/8 of an inch long. How long does the extension line go past the arrowhead? Approximately 1/8 of an inch. How far out should a dimension be from the object? About 3/8 of an inch. If you stack dimensions up, about 1/4 of an inch. This used to be really interesting. I remember back in college, I had quizzes on how to actually do your letters. There are a specific sequence of strokes to draw a letter or a number. And then we used to have to dimension all of this stuff and write it in here. It's nice because CAD actually does most of this for you, but you still need to know the standards because the computer can't always get it right, so you must be smarter than the computer to be able to fix it. Let's look at isometric projection drawing, the next type of drawing that we do. Everyone enjoys drawing isometrics more than they enjoy drawing multi-view orthographic projection drawings. So what is an isometric drawing? Well, an isometric drawing is a way to draw an object, actually make it look like it would in real life, to make it look like it's three-dimensional, even though it is not truly a three-dimensional drawing. Isometric drawings are usually drawn, show the object in finished shape, and they are drawn at 30 and 90-degree angles. So this is what makes an isometric drawing. Vertical lines are drawn at perfect 90-degree angles, but then all the other sides are drawn at 30 degrees going to the right or 30 degrees going to the left. Kind of looks 3D, but it is a little distorted. We call this an isometric drawing because iso means that all angles are equal, but you think, well, how is this equal if we're using 30s and 90s? If you look at these three angles right here, this is a 60-degree angle, this is a 120-degree angle, this is a 120-degree angle, and this is also a 120-degree angle. Isometric drawing in CAD. So drawing is set to an isometric snap. Thankfully in CAD, we have a feature where we can actually set these to these correct angles. In fact, when you're using AutoCAD or ProjeCAD, the F5 key on your keyboard will toggle you between your three isoplanes that you would like, top, front, or side. So if you're on a top isoplane, your cursor is going to look like an X. If you're on a right isoplane, one cursor line will be going up and down, the other one will be going at a 30-degree this direction. If you're on the left isoplane, one angle of your cursor will go at a 30 this direction, one will go vertical at a 90. And if you notice, isometric circles are not circles, they're actually going to be drawn as ellipses. Something to keep in mind when we get to that point of drawing. Now, last thing we want to talk about is a working drawing. And what is a working drawing? Well, that's basically when you can combine those orthographic and isometric drawings together and add some information like finished part sizes, a materials list. It's called a working drawing. Basically, a working drawing will be a drawing packet that contains all of the information needed to manufacture a product. They typically contain those orthographics and isometric drawings of all the parts, and the isometric assembly typically shows the assembly of the object as well. It shows how the parts go together. Many of you have probably already seen exploded isometric drawings where they show you how to put the parts together. Say you bought a model or you bought a piece of furniture with your parents, then you had to put it together. You got isometric drawings that show you how to put it all together. Parts lists are typically included to show also the finished sizes and the materials of each component. Here are some examples of some working drawings, and actually one of these we are going to be doing. Our project in class will be to generate this gumball machine drawing. So here would be the isometric drawings of all the parts of the gumball machine, and this is what we call, again, an exploded isometric. It's like all the parts have been blown apart and they show how it all goes together. They have bubbles and numbers that correspond with this materials list. Here's an assembled view of it. Here are all the orthographic projection drawings of the part, and this would be the gumball machine that we actually manufacture when we get to our manufacturing unit. So we're going to actually draw some of the parts of this gumball machine, and then we'll just assemble the other ones. We just do not have the time to draw all of these parts, but it is a very complex and very interesting looking drawing. Great for a portfolio. And that's the end of this presentation. Good luck with our CAD unit.